Let's quickly start with today's class. Before that, let's go through what you've done to the last class, and then we'll start with today's session. Okay. All right, guys. Coming to today's session, we have been in the topic for arrays. We have done the data structures part of the arrays. Now we are currently doing the algorithm part. So in terms of algorithm part, we have covered linear search, binary search, replacement, insertion, deletion, all those things. We have done with the two pointers and the question based upon two pointers. Prefix array as a concept we have covered. Question is what we are covering today's session. So the agenda for today is let's cover all the question related to prefix sum, and then we get time we can cover some more algorithmic questions. Okay. Prior to that, we have already talked about time and space complexity and recursion and all those stuffs. So yesterday we did a very good question, the first question on LeetCode and one of the most importantly asked question, which is called 2sum. I'll talk about the generic solution that we come and then we can talk about the solution we submitted on the LeetCode. So the problem of 2sum, it has variation for like 3sum and other as well. The question is you're given an array of size n and a target. You need to find the pairs with sum equal to target. So array is given, target is given, you need to find the pair. Now this question can have three variations. Number one, of course, there can be more than one pair. First thing first. Three variation can be, you can be asked to print the pairs, number one. Number two, you can be asked to count the number of pairs. So this can be output two. Or number three, you can be asked to print the indices of them. So it can be three possibilities, right? Now we solve the solution based upon generic one and then we'll go to the LeetCode one. So the generic solution for this question is three solution. You can solve it in brute force, you can sort in sorting and two pointers, then you can solve it in hashing as well. What's the brute force approach? The brute force approach says since you have to find two numbers, a plus b equal to target, what you can do is you can run one loop for the first number, second loop for the inner number, and then nested loops you can get the answer. So my time constant will be big of n square, my space constant will be big of 1, two nested loops. Okay. Then you have sorting and two pointers. So what does that sorting and two pointers means? So before going to sorting and two pointers approach, I first covered about the sliding window and the two pointers part. What is sliding window in general? Sliding window is a superset of the algorithm and two pointers is a subset of the algorithms. What do you mean by that? When we say sliding window, we talked about two variable pointers which can move in either directions. So let's take I and j. I can move in either direction, j can move in either direction. That's the reason we call it a sliding window. I and j both are movable, so we can increase the window size, we can shrink the window size whenever required. And this is the case of unsorted array or sorted array. It will work in both the cases, right? That's why we call it as a superset. One of the subset of sliding window is what we call as two pointers. Why do we call it as a subset? Because number one, it works only on the sorted list of values. When we say it works only on the sorted list of value, we do not put the first and second pointer anywhere randomly. We purposefully put the first pointer pointing at the beginning and the second pointer pointing at the end. Okay. And just like the sliding window, it does not have a unshrink movement. So it has to move in a specific direction. So for the first pointer, which is pointing to the beginning, it can only move from left to right. So that way I have to increase the value, I can move left to right. And the last pointer, it can only move from right to left. So I can decrease the value. Okay. I will never go I minus minus here. J will never go J plus plus here. That is what two pointers is. Now coming specific to this question, which says sorting and two pointers. Why we need to sort the array? Because as we discussed, two pointers can only be applied on a sorted array or sorted list of values. In my given question, the array was not sorted. The question nowhere said that the array is sorted. So we have to sort the array, then we need to apply two pointers. So we start with this array with the given the target equal to 6. We need to find a pair which will give some equal to target and we'll get the output. Okay. So if I start with this, let's say 1, 2, 3, 4, 5, target is equal to 6. I can compare array of L plus array of R given is equal to target. Now, if I want to know other values also, for example, L plus plus, if I do, L will become 1, R will become 4. My current sum is greater than target. If your current sum becomes greater than target means I need to reduce the sum. Reducing the sum, I have only two options. Either I can increase the value or decrease the value. So for decreasing the value, I can move from right to left. So I will do R minus minus or J minus minus. Similarly, if my current sum is less than target, means I need to increase the current sum. So I can do left to right. So I can do I plus plus or L plus plus. Okay. Then we move to the code part. So in terms of coding, the first thing is I'm going to sort the array. After sorting the array, I can apply two pointers. I'll keep two pointers, first pointing to the beginning, last pointing to the end. While left is less than R, or I can say I is less than J, what I can do is I can compare the three scenarios. If it becomes equal to target, I got my count. If the current sum is less than target, I do I plus plus. If current sum is greater than target, I do J minus minus. Okay. The time complexity of two pointers is big of n, but the time complexity of sorting is n log n. So if I talk about the entire approach, it is n log n plus big of n, which becomes n log n. Space complexity remains big of 1. That was the second solution. Now, third solution for this question is based upon hashing. So either we can use a set or you can use a map. What is the hashing based approach? Let's talk about it. The hashing based approach is you need to find a plus b equal to target. If I tell you you have a in your hand, so technically you need is target minus a. For example, if I want the target 6 and the current value is 1, All I need to do is I need to check whether 6 minus 1, 5 is present or not. Because if 5 is present, I got my answer. Otherwise, it is not answer. Okay. So all I need to do is I need to check if temp, which is target minus A, is present in the array or not. If I check that via an array, that will be a linear search. And if I have to check for all the values, time complexity will become n into n. So that will become big of n square. So I'm going through each and every value, and then I'll check if target minus array of y exists in the array or not. So that will become big of n square. That takes us back to the brute force where we started with. Okay. That's the reason we implemented by using a map or using a set, because a lookup time in a map or a set is always big of 1. Okay. So if I'm trying to find target minus a exist in a map or a set instead of an array, in that case, I can find that in big of 1. So outer loop will eliminate symbol big of n because I have to check for all values, but that lookup time will become big of 1. So n into 1 will become big of n. Space complexity becomes big of n because I'm using a set or a map here. I talked about the reason to use set or a map. We have the search lookup in set map big of 1, search lookup in unsort array is big of n. And then we talked a bit about what is a set. Set contains only unique elements. It will not contain any duplicate. We talked about map, which looks like a JSON schema and which contains a key value pair, lookup time for insertion, as well as the lookup time and insertion time is big of 1. Space complexity remains big of n. Okay. Here's the code we talked about. If I have to check in a set whether it exists or not in C++, in Java, I would just type dot contains. Now coming to these are the generic solutions. If the problem comes, whatever variation comes, we should be able to solve with these three variations, third being the most optimized. Now coming to the specific variation of this question. The specific variation is if the question says that you're given a sorted array. If I'm already given a sorted array, then I can directly apply 2 pointers. Well, technically both 2 pointers and hashing will have the same time complexity, which is big of n. But with 2 pointers, I don't need to create an extra space. With hashing, I will need to create an extra space, either a set or a map, right? So space complexity remains big of 1, 2 pointers remains big of n. That would become the best solution. Okay. If the question asks about returning index, so we talked about if I have to return the index, then should I use for sorting approach? The answer is no, because if I use sorting, my indices will change, and the entire question is about returning indices. Make it a thumb rule: whenever the question is about ordering or indices or anything in general, do not answer by the sort. Do not go with the approach of sorting. Okay. So this is the lead code variation where we use an unsorted array. We are using a hashing based solution. And the difference between when to use map, when to use set, if it contains only unique elements, go ahead with set. If it contains duplicate element or possible to contain duplicate elements, then go with map. In this question, we can contain duplicate elements. And until and unless the question very specifically says unique elements, please do not assume anything from your end. Okay. So coming to the code part, what we do, we create a hash map here with the key is the element, value is the index. We check if map.contains. If it contains, I'm storing the indices, returning the indices. Otherwise, I'm just putting the value with the element and its corresponding index. We did that on multiple test cases to understand that past or test cases. Time comes to big of n, space comes to big of n. After doing all this, then we start with the prefix sum, and that's the question we'll be doing for today on 2 or 3 questions on top of prefix sum. First, talking about the concept. What is the concept of prefix sum array slash running sum array slash cumulative sum array? The idea of prefix sum or running sum or cumulative sum is that if you're given an array of size n, the prefix sum array is another array of the same size n such that prefix sum of I is sum of all elements until I, or sum of all elements until index I. So array of 0 plus array of 1 plus array of 2 till array of I. So sum of all elements up to array of I. So if I talk about this array 10, 20, 10, 5, 15, I talk about prefix sum. If I calculate the prefix sum, it would be like 10, 10 plus 20, 30, 40, 45, and 60. Based upon this knowledge, if we write down the code, we write down a two nested loops code, we calculate the prefix sum, time comes to become big of n square, space comes to big of n, considering that we have to create a new array. But if you observe carefully, if I just use basic mathematics here, I can see prefix sum of I is prefix sum of I minus 1 plus array of I. Now, this is a very important statement. First thing first, this is giving me a trigger alert that I can use recursion here, because if I write a function of prefix sum, I'll be technically calling itself with the definition of I minus 1. So number one, it's a trigger alert. Number two, let's understand what this equation is telling me. This equation is telling me that if I have to calculate the sum of values till I don't need to start from the zero. Basically, I don't need to start this inner loop. I just need to take the sum of values till I minus 1 and add array of I to it. Okay. So we implemented that approach. Based upon this approach, we got the answer time constant big of n and space constant big of n. This is what we have discussed in the last class. I've given two homework questions, which I'll come back to it. But this is what we discussed in the last class. Quickly give me clear if everybody clear with the revision. Any question, please ask in the chat. Let me open the chat window in meantime. All right, time complexity n log n. Yes, sorting has a complexity of n log n. That's why it was n log n. Okay. All good. Could just prefix example. Could just tell prefix example. Prefix example in the sense. You're referring to this example. This is prefix sum example. 533 line number. 533 line number. This is the function to calculate prefix sum. Are you talking about how does this function come? Okay, so based upon this, if I have to calculate prefix sum for an array, it's prefix sum of I minus 1 plus array of I. So what I'm doing is prefix sum of 0 will remain array of 0. Then I go from 1 to n. Then I'm just putting this logic, prefix sum of I is a prefix sum of I minus 1 plus array of I. This is. Okay. Cool, guys. Now coming to the homework, let me have a quick status check. How many of you have done the two sum two part first? One moment, one moment. Yeah, I'll come to your question, but let me see the homework part first. Anybody has doubts, anybody is not able to solve, let me know. Okay. How many has done the line 533 used heap memory over stack? Is there any benefit over stack? 5353. Um, I don't get which line you're referring. 535. Okay. 535. I've used heap memory over stack. Is there new? No, it doesn't matter. I mean, you can create with the new. The new one will always use the heap memory. It doesn't matter any difference. Okay. It's not a vector. It's an array that I'm creating. So if you create with the new operator, it will just create in the dynamic memory. It doesn't make any difference. Okay. All right, guys. Next question. Threesome. Anybody has any doubts in threesome? Any questions? Anything somebody is not clear? Any doubts? Okay. All right. If everything is good, I can start with today's session. I saw one question. I'll just scroll back to the chat and then I'll give an answer. Yesterday, I have a doubt. I tried to solve it. Not alt test case path. Initiate left equal to 1. Left equal to 1. Which question specifically? For left equal to 1, which question specifically? You can select. Okay, you're talking about one moment where it is. Let me know which question you're talking about before I give an answer. You can initialize with left equal to 0. One moment. You can initialize with left equal to 0 and then you can continue. Expected time complexity of threesome is big of n. Same using the hashing approach. Okay. All right, guys. You just need to use two hash maps. That's it. Execution time is relative. Think on the time complexity rather than the execution time because execution time is relative, right? It will never be the same. All right. Cool, guys. I think most of you are done with the questions and the homework. Let's start with today's session. Give me one moment, guys. Input array sorted if I'm taking left equal to 1. I need to see your code, what you mean by left equal to 1 here. But if you're talking about two pointers, I and j, if you can keep one, you can keep it I equal to 0 there. This should pass our test case. Is there a specific test case which it did not pass? Let me know because most of the people are able to solve. So might be one edge case that you missed. Okay. First pointer pointing to the 0, last pointer pointing to the n minus 1. That's the approach. Index 1 initiate equal to 1, index 2 equal to n minus 1. Index 1 initiate equal to 1. Okay, so what you can do is you can keep the index as n minus 1 or I minus 1, whatever that is, because indexing in array will always grow from 0 to n minus 1, right? But I think the question specifically talked about one base indexing. So you just need to do I plus 1 there, right? Just because the question says one base indexing doesn't mean the array index will start from 1. The array index will still start from 0. Okay, so that index you need to take care by putting I plus 1 there. Okay. All right, guys. If you have more questions, let me know your code, then I can look up into it. But I think that should be good enough. You figured out the case. All right, guys. One moment. Arrays.sort, j less than k, array list. So you're implementing a sorting based approach. Think about a hash map. Okay. You have a set of list of integers set, arrays.sort. Why are you sorting as well as using a map? It should be one of the approach, not both of them. Okay. Yeah, you put L equal to 1, put L equal to 0, put L equal to 0. That's the code. Okay. And that L equal to 0, wherever you're putting the answer, new integer, I don't know where you're putting the answer. Where you're putting the answer, just put L plus 1. L plus 1, R plus 1. That's all. Okay. All right, guys. Sort and 2 pointers within square and you optimize code. Hash plus based solution. Hash map based solution. Okay. Yeah. Try with that. Cool. All right, guys, let's go to the questions of the prefix sum. That's something I want to cover. And then we can continue with if any questions are still pending. Okay. All right, guys, prefix sum as a concept. Any doubts anybody has? As a concept, anybody has any doubt? What is prefix sum? How do we calculate it? Let me know. If not, then we can go to move with the questions. I'll take a couple of questions here, then I'll go to the other good questions for other algorithms. Starting with question number one. This question has been asked in Microsoft. We'll start with the question. The question is called equilibrium index. So find equilibrium index in an array. Okay. So the question would be something like this. When we say equilibrium index, we need to define what exactly is equilibrium index. So equilibrium index means in an array is an index such that sum of elements on its left is equal to sum of elements on its right. Equilibrium index in an array is an index such that sum of elements on its left is equal to sum of elements on its right. So if I talk about index I being an equilibrium index, I can say sum of array of 0 till I minus 1, not till I minus 1 is equal to sum of array of I plus 1 till n minus 1. So if I say any index is equilibrium index, let's put it this way. This is how it will look like. Sum of values on its left is equal to sum of values on its right. So this part value sum 0 to I minus 1 will be equal to this part value sum I plus 1 to n minus 1. That is when you claim something is equilibrium index. Let's try to understand with an example. If I talk about array -7, 1, 5, 2, -4, 3, and 0. What do you think is the equilibrium index here? Quickly in the chat. Do you think there's any value which can be considered as equilibrium index? Guys, index. What do you think is the equilibrium index here? Anybody? Okay. If you look at index 3, let's talk about, a lot of people are talking about 3. So let's talk about index equal to 3. If I talk about index 3, there would be a left part which will be from 0 to 3 minus 1, which is 2, which is 0 till 2. And there will be a right part which will be from 3 to whatever n minus 1. So 1, 2, 3, 4, 5, 6, 7. So 6. If I talk about left part, which is -7, 1, and 5. And right part, that is -4, 3, and 0. So my left sum becomes what? My left sum becomes -1. My right sum becomes what? My right sum becomes -1. Left sum and right sum become same. That is why index 3 will be considered as a equilibrium index. Everybody crystal clear with this? Come on guys, quick in the chat. Everybody crystal clear with this? Okay. Basically, that's what the question is. Now, obviously, there would be edge cases. So we'll talk about the edge cases and then we'll talk about it. First edge case. By the way, these edge cases interviewer won't tell you. Line 48, 4 to 6. Oh yeah, 4 to 6. By the way, these edge cases interviewer won't tell you. You have to come up with the edge cases by the way yourself. Interviewer will tell you till this part. Let's say explain the question, give one example, that's it. What can be the edge cases in here? You need to come up with the expectation is from you that you will think about all the edge cases, various scenarios, and then come up with the solution cumulative of those edge cases. So first edge case that we can think is, can there be multiple equilibrium index in the first place? Because if you're talking about equilibrium index, is it just one value which can be equilibrium index or can be multiple values which can be equilibrium index? What do you guys think about this? Can there be multiple equilibrium index in an array? Okay, some of you are saying yes, some of you are saying no. Quickly in the chat. Is it a possibility to have multiple equilibrium index? Okay. Let's talk about this. 0, 0, 0, 0. Which index is equilibrium index here? Come on, guys, quick in the chat. Which index is equilibrium index here? Okay, let's see. If I talk about 1 and 2, definitely they're equilibrium index, no doubt about it. If I talk about left part, index 0, what is the left sum? What is the left sum for index 0? Left sum is nothing, left sum is 0. What is the right sum? Right sum is 0. So index 0 is also an equilibrium index. Similarly, if I talk about index 3, right sum is 0, left sum is 0. So all indices are equilibrium index. Okay. If I talk about r equal to 10, what is the output here? What is the output here? Guys, you have to print indices. You have to print indices. Is 0 equilibrium index? Yes or no? Is 0 equilibrium index? See, understand the basic thing here. The element which is called an equilibrium index, the element at that index, would it have any impact on equilibrium index? Think about it and then tell me. The element value at equilibrium index, will it have any impact on the equilibrium index? What do I mean by that is, if this is 2, if I make it 20 or 2000 or 20,000, will it change answer in any way? Correct. It will not change the answer in any way. Why? Because this value is never used. So no matter you give a positive value, negative value, how bigger the smaller value, doesn't matter, because left sum does not contain this, right sum does not contain this. So irrespective of whatever value is present there, it doesn't change the answer anyways. So if I talk about this one, if it contains only one value, if the array contains only one value, it will always be equilibrium index with index 0, because left sum, right sum doesn't matter. It will always be 0. Okay. So here my left sum becomes 0 and my right sum becomes 0. The value at 10 doesn't make any difference. If I talk about an empty array, what is the output now? What is the output now? Guys, if there's empty array, there is no 0 index. Correct. Empty array cannot have equilibrium index. Okay. Last edge case, can even size array have equilibrium index? Is equilibrium index only possible for odd size array, or can even size array also have equilibrium index? Those who are saying yes, give me an example. Those who are saying yes, give me an example. See, this was the example that we just took, all 0 values. But even apart from that, we can think of any other example. For example, 6, 10, 3, and 3. So if I talk about this, what is the equilibrium index here? 1. So it has nothing to talk about whether it's a odd size array or even size array. Even size array can have equilibrium index. Okay. So coming back to the question now. This is the question which will be given to you by the interviewer. All of these edge cases you have to come up with. Interviewer won't tell you that you have to think of the edge cases. So first think about, can there be multiple equilibrium index? Possibility is there. So should I take care of returning an array as an answer? Should I just return integer one value? So should I return first equilibrium index or should I return all equilibrium index? That's something you need to discuss with the interviewer. Part 1. Mostly interview will say that the question or the test cases are such that, one moment, question or the test cases are such that it contains only one equilibrium index. You can return one equilibrium index or the first equilibrium index, whatever that is. Second is, you have to think about the edge case where it contains, array contains only one element. If array contains only one element, output is 0. It will always be equilibrium index. If array contains no element, means equilibrium index is not possible. So output is -1. See, -1 in index denote invalid case or error case, right? So whenever you are finding a question related to index and the output is -1, means it does not exist. That's why the output is -1, does not exist. Okay. I should have mentioned here, find equilibrium index in an array and return -1 if it does not exist. Okay, that's the question. Now coming to it, it can be also an edge case. So what about the even array and odd array size? Both even array and odd array size can contain the equilibrium index. So output is still 1 here. That is what the question is. Any doubt in the question? Anything which is not clear? Everybody crystal clear with the question? What is the expectation? What you need to do? Okay. So if that is clear, let's talk about the function that you have to write. Function that you have to write is this one. Integer equilibrium index. We'll just make it a small. You will be given an array. You'll be given the size of the array. That's you'll be given. All I need to do is you need to return me what is the equilibrium index. If there are multiple, just return me the first one, or assume that there's only one equilibrium index. So let me take this, put it in the chat. Feel free to complete this function in any language of your choice. Please validate with the test cases that I have given. I have given four test cases, and if you take 5 test cases, also validate with your test case that you can think through that. Okay, at least these 4 to 5 test cases your code should work upon. That being said, guys, everything is clear from my end. Let's take the pivot index. Yeah, the question is available on multiple websites. If you want to solve on LeetCode, we can solve on LeetCode directly. Let me open that question real quick. Yep, that's the exact question. Good one. Let's directly solve here. It will save us time. Cool. All zero means return the first index. All zero means return the first index. Yeah. I mean, let's solve directly on the LeetCode one. N is the size of the array. Wherever n is given, it's the size of the array. It's good one that we have. We have this on LeetCode and Geek4Geeks and my other website, but let's directly solve it on the LeetCode first. Okay. So the question is LeetCode 724. I assume that my screen is visible to all. Let me know in the chat. I assume my LeetCode screen is visible to all. Come on, guys, quick in the chat. Okay, cool. The question is LeetCode 724. If you talk about the submissions, 2.2 million submission, 59.9, almost 60% acceptance rate. And if you talk about the companies which have asked this question, a lot of good companies have asked this question. Now coming to the problem statement, given an array of integer nums, calculate the pivot index of the array. The pivot index is the index where the sum of all numbers strictly to the left of the index is equal to sum of all the numbers strictly to the right index. If the index is on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Same logic. Return the leftmost pivot index. This is the first one, the first pivot index or the first equilibrium index. If no such index exists, return -1. Everything that we talked about, same thing. Example, they have given 173656. So if we talk about this 6 left sum will become 7 plus 3 plus 1, which is 11. Right sum will become 11. So output becomes 3 here. If I talk about 1, 2, 3, in this case, there is no element, so output become -1 here. 2, 1, -1, if I talk about this, output 0 because 1 minus 1 will become 0 on the right side, left sum it is always 0. Okay. This is the question. Length is given as 10 to the power 4. So big of n square will also pass. Values are small, 1000 to 1000. And it has the same question as 1991. So technically by solving this question, you are solving two questions. Find the middle index in the array. Let's talk about that as well. So technically by solving this question, you have solved two questions precisely. Same question here, given 0 index array, find the leftmost smallest among the all possible ones. Index is 0, nums of 0, nums of 1, so on and so forth. Middle index 0, left side considered to be 0, same logic. Rightmost considered -1, same logic. If I talk about this, 2 plus 3 plus 5 -1 is 4, and for 8, the right value is 4. So output becomes 3, the index of 8, and so on and so forth. Okay, so that's a good one. We technically got two questions to solve now by solving one question. So let's take that on. Sublime text will mention that question here as well. Let's go back. Let's go to Sublime text. Let's come here. Okay, here we go. Equal to the index, right? Let's correct this. Everything looks good. Example is here. Explanation is here. Example 2 is here. Explanation is here. Example 3 is here. Explanation is here. Okay, I'll mention, don't worry. Let's take this guy. Read code 724. Okay, and this is the same question as this one as well, 1991. So technically, we'll be solving both of them. So let's take this guy, the code that you have to complete. This is the function that you have to complete. pivot index. Let's take this guy. If you look at this function, it's returning an integer. So you have to return the leftmost one or the first equilibrium index slash pivot index. And that's it. You're given an array. You don't need any other input. Any doubt in the question? Exact same question, just on lead code. Any doubt in the question? Anything which is not clear? Let me know. All good? Cool. I'll just put it in the group chat. You guys know what to do. This is the lead code link. And this is the function that you will need to complete. Feel free to code in any choice, whatever language of your choice, and submit it and share the submission link with me. Okay. Everybody clear, guys? Any questions? Anything which is not clear on the question? Anything you want me to explain? I'll count to 3. 1, 2, 3. Okay. I'll take that it's clear. Cool, guys. If everything is clear, please change your message directly to me. Do not message to everyone. Just directly code on. Both are same question. I mean, 724, 1991, both are same question. That's why. Same code will work there. We can verify that. Okay. All right, guys. That being said, let's start solving on it. And once we are done, then we can have a discussion. That's what the question says. That's what I repeated also. So assume even if there are multiple equilibrium index, you have to return the one on the leftmost one. Okay. The question very specifically said it. So first one or the leftmost one you have to return. So forget about can be multiple. It can be multiple too, when we be very honest. So you have to return the first one. So you have to don't worry about returning all of them. Okay. All right, guys, that being said, let's get started. Can you explain how to check complexity and square is possible? Guys, I have covered this multiple times. Please revise the session. That will help you understand. And for your knowledge also, it will help you understand. So I covered a trick of competitive programming. In that competitive programming, I told you about we can do 10 to the power 8 computations, which is 100 million computations. So what you do is you compare the highest constant with 10 to the power 8, and that's how you can figure out whether n square can pass or n log n can pass or big of n can pass. Okay. I would ask you to revisit that recording or go through the notes, whatever works for you, and that will help you understand in detail. But just to answer your question, this is the reason. Okay. All right, guys. Anything else? Anything which is required from my end now? Just do it quickly, guys. We have to solve more questions. I don't want to stick to 1 or 2 problems in 2.5 hour session. Okay. Cool, guys. That being done, please change your message directly to me. Start solving it. Once you guys are done, share the submission link, and then we can have the discussion. Your time starts now. Okay. Cool. I think most of you are good to discuss. I don't see anybody mentioning in coding. So let's discuss the solution. Okay. While we discuss it, tell me first thing, how many of you are able to solve it in less than big of n square? Anybody who's able to solve in less than big of n square? You can message to everyone now. We're not accepting any solutions. So you can just say yes or no. Okay. The couple of you who are able to solve it. Some of you are able to solve in less than big of n square. Some of you are still solving in big of n square, which is fine. Let's talk about the optimization later once we come up with the working solution. Okay. All right, guys, let's quickly start here. But I could not complete one test case is failing. We'll talk about it, whatever the test cases are not there. Okay, let's talk about the solution number 1. First, we'll start with the brute force approach or the naive solutions. Brute force is using 2 nested loops. What is 2 nested loops? For every element, we need to calculate left sum and right sum. For each and every element, we'll calculate the left sum and right sum. Space complexity big of n, fine. Feels fine. Space complexity is fine. I'm more concerned about the time complexity, how we've used it. Okay. Now, first thing first, for every element, I'm going to calculate left sum and right sum. If left sum becomes equal to right sum, that is when I'll claim that that is my equilibrium index. All agree? That's what the logic. So in a brute force way, what I can do is I can go to each and every element. For each and every element, I'll be calculating its left sum. I'll be calculating its right sum. If left sum and right sum become same, that is when I can say that particular index is equilibrium index. All agree with this? Come on, guys, quick in the chat. All agree with this? Okay. So let's talk about this. Arrays, let's say 6, 10, 3, and 3. What is the output? The output is 1. So what we'll write in the code? Let's say pivot index or equilibrium sum, whatever you want to call. The way we'll implement this code is first we'll define integer left sum equal to 0. I'll start with integer right sum equal to 0. Right? And what do we do here? After this, I'll write a code I equal to 0, I less than n, I plus plus, and let's quickly define I and j here. Integer I comma j and integer n equal to nums dot length. Something like that. Now, what we do here, first thing first, I have to go to each and every element. So for each and every element, I'll define my left sum is equal to 0. For j equal to 0, j less than I, and j plus plus. I will say left sum plus equal to nums of what? Nums of j. So that gives me a sum from 0 till I minus 1. Okay, 0 to I minus 1. And similarly, I can do it for right sum. So right sum becomes 0 for j equal to I plus 1, j less than n, and j plus plus. My right sum becomes what? Plus equal to nums of j. That is from I plus 1 to n minus 1. Okay. And then I can return, well, let's put one condition here. If my left sum becomes equal to right sum, I can return that index I. If not, then I can return minus 1. Everyone clear with this approach, the brute force approach? What am I doing in this brute force approach? Let's mention here a test code. What I'm doing in this brute force approach, I'm going through each and every element. In each and every element, I'm checking the left sum part, calculating the left sum for that, calculating the right sum for that. If that particular element is the equilibrium index, I compare. If left sum becomes right sum, equilibrium index, pivot end element, whatever you want to call, I return that particular index. If I get out of the entire array values, if I get out of the entire indices, none of them is equilibrium index / pivot element, I can return minus 1 here. Everybody crystal clear with this approach? Any questions, any doubts, any follow-ups? Clear? No doubts? Cool. What is the time and space complexity of this code? What do you think is the time and space complexity of this code? Correct. The outer loop, if I talk about this guy, that is becoming big of n. The inner loop, if I talk about, it's running from 0 to I, and that is running from I plus 1 to n. It's running from 0 to I, and that is running from I plus 1 to n. So technically, apart from one index value, it's running n minus 1 time, but you can say like it's very much big of n. So time complexity will become big of n square. Space complexity, I'm not using any extra space, so space become big of 1. All good? Easy solution, easy to implement, easy to understand, explain everything, but there's a problem. The problem is the time complexity is big of n square, which is a very high time complexity. So what do we need to think? We need to think of the optimization. Can we solve this in less than big of n square? The answer is yes, we can solve it in less than big of n square. How can we solve this? Let's talk about the optimized solution. Optimized solution or approach is prefix sum array. What we can do in the optimized solution, let's talk about this real quick. So as part of optimized solution, I'll walk through the approach first, and then we'll go to the code part. Okay. Why prefix sum array is useful here? That's understand in the first place. So you should be really good in solving problems to get an intuition that whether you have to use a prefix sum or you have to use some other thing or some other algorithm, right? The intuition for prefix sum using here is number one, we are talking about the sum of the array, left sum or right sum. Anyways, we're talking about sum of the array. So that is the major intuition we can utilize the prefix sum here. And then we are going to use a mathematical trick to find out how we can reduce that big of n square to big of n. Okay. So let's have the approach first. We initialize the left sum is equal to 0. And carefully see the approach. We initialize the left sum equal to 0. And we get the total sum. We get the total sum of array, which we call as total sum. Okay. Space comp depends on any extra variables we create, depends. If I'm creating extra variables, the space comp is still big of 1. But if I create these variables inside a loop, that will become big of n. Okay, so it depends where you're creating it. Okay. Anyways, coming to it. Listen to this approach. This is a very interesting approach. It's a simple mathematical trick, but that simple mathematical tricks actually saved us from big of n square to big of n. So what we're going to do here is we initialize two variables, left sum and total sum. We do not define anything called right sum. I'm repeating it again. In the previous approach, we have left sum and right sum. There was nothing called total sum here. Okay. In this approach, we are defining left sum and total sum. Total sum is nothing. It's just a prefix sum, right? Running sum, total sum, cumulative sum, whatever you call it. So we define left sum, we define total sum. There is nothing called right sum here. What we say is that total sum becomes total sum minus array of I, and that is what we are claiming to be the right sum. And this is the whole mathematical trick. Then we compare left sum becomes equal to total sum. Wherever it becomes that, we return that index I. And then we update the left sum. How do we do that? We say left sum plus equal to array of I. The entire trick of this question, or the entire trick of this entire approach, is line number 217. When we claim that total sum become total sum minus array of I. Okay. It's completely fine if you get it. Total sum minus left sum minus array of I equal to right sum. No, total sum minus array of I is equal to right sum. It's completely fine if you get it, or if you don't get it, once we go to the code, we'll go through that. No, it is not wrong. It is correct. It is correct. What we are saying is total sum minus array of I becomes right sum. Okay. Anyways, anybody who's able to understand this at this moment, anybody who can understand this at this moment, it's fine if you say no, it's fine if you say yes. Okay, one of you, okay, few of you are saying yes, most of you will say no, which is completely fine. It's fine, guys. If you don't get it, we'll go through the code. We'll try to understand what is happening here. All I'm saying is it's simply a mathematical trick, nothing else. Once I'll explain to the example, you'll get it. It's simply a mathematical trick, nothing else. No, I've not explained. I have not explained yet. I'm just saying this is the trick. How we go through it, we'll go through. I've still get to yet go to the explanation part. I've not explained anything yet. Okay. Let's go to the code part first, and then we'll talk about it. So let's take this guy, pivot index. These value will remain the same, so nothing to change here. This remains here, this remains here. Okay. Now, what did we talk about? We talked about this going to be a left sum and this going to be a total sum. There's nothing called right sum. Repeating this part again, only left sum and right sum, nothing called total sum. And we don't need j, so I'm removing j here. I equal to 0 is fine. What we do is we defined I equal to 0, I less than n, and I plus plus. First, we calculate the total sum, which is total sum of the array. So total sum plus equal to array of I. Any doubt till this part? One moment, guys, one moment. Any doubt till this part? No. Cool. We calculate total sum of the array. To your question, we don't need a separate array. Now what we do? For I equal to 0, I less than n, I plus plus. Observe what am I doing here? I am saying total sum is equal to total sum minus array of I. And this is what I'm claiming to be the right sum. This is the entire trick of this question, line number 246 written here. And then I'm comparing if left sum becomes equal to total sum, which is now the right sum. I return its index I. If not, I'll update the left sum part. So left sum becomes what? Plus equal to array of I. And if I get out here, I am not able to find anything, I return minus 1. This is what the entire approach is. Now, what is this mathematical trick? This is something important. Array is nums of I, same thing, whatever the names of the array. Nums of I. Nums of I. What is the interesting part here is I less than n. What did we miss? I plus plus. This is fine. This is nums of I. Okay. What are we actually using? This is a very interesting trick to use. And when we say total sum minus nums of I, and we are claiming this to be right sum, this is the critical part. It's super simple. It's nothing too complicated of a mathematical equation I'm using here, but super simple. But that super simple trick saves us from big of n square to big of n. Let's try to understand what exactly I'm doing here. So I'll explain this example that you have taken. What was it? Minus 7152, output 3. Cool. Let's bring this guy here. Okay, this was our array and output was 3 here. Now, just help me understand one thing. If I talk about total sum for this array, can you guys quickly tell me what is total sum of this array? Quickly in the chat. Quickly tell me what is total sum of this array in the chat, real quick. Sum of these values. Come on, guys, simple maths, quick in the chat. What is the total sum? The total sum becomes 0 here. All agree? Sum of all elements here, the total sum will become 0 here. All agree with that? Okay. Now I start with I equal to 0. So until this part, we got the total sum becomes 0. Now I start with I equal to 0, which is the first element. So at I equal to 0, can you tell me this line will be executed? Total sum will become total sum minus nums of 0, correct? We calculated total sum becomes 0 here. Now we come here with I equal to 0. This was the first line which will be executed. Total sum will become total sum minus nums of 0, which we are claiming to be right sum. So total sum was 0 minus nums of 0. What is nums of 0? What is nums of 0? Let's call it as nums. Minus 7. What is 0 minus minus 7? Quick in the chat. Plus 7. Okay. I am claiming this plus 7 to be the right sum. That is what this line said. Yes or no? I am claiming the total sum minus nums of I is right sum. That's what I said. Agree? So technically, I'm saying that 7 is my right sum. Now, can you guys do me a favor? For this I equal to 0, this part is the right sum. Can you quickly calculate the sum and tell me in the chat what is the sum? Come on, guys, quick in the chat, validate by yourself, then tell me what is the sum. Is the right sum equal to 7? The right sum is equal to 7. So my trick is working. Mathematical trick is working. It's giving me the answer. Output remains, and that trick has reduced the lead for another internal loop. So time constant remains big of n. Now the interesting part. How did total sum minus nums of I becomes right sum? Okay, first thing first. Everybody clear the trick is working? When we say total sum minus nums of I, it is equal to right sum. Everybody is verified by themselves. Okay. Now the second part, how exactly the trick is working. The trick is super simple. I have not done anything magical here. All I've done is I claimed that I'll take the sum of the entire array. So I took the sum of the entire array, which I call it as total sum or cumulative sum, whatever you call. Then I'm saying I will carve out the nums of I. So if you carve out the nums of I, what you are left with the right sum. If you take out the left sum out of total sum, only value that you're left out is right sum. Yes or no? That's all I have done. This was my total sum. I took out this value. So if I took out this value, the right value will become only the right sum. Anybody has any doubt in this? Come on, guys, quick in the chat. Everybody clear with the approach? All I have done is I have played smart here mathematically. How did I play smart here? Instead of calculating left sum, right sum for every element, which I was doing, and that intuition came from here, by the way. How did the intuition of optimization came? The intuition of optimization came from here. Because for every element I was calculating left sum, for every element I was calculating right sum, that will creating me big of n square code. Instead of that, I know that left sum plus right sum gives me the total sum. If I calculate total sum at once, I calculate total sum at once. I took big of n code here. After that, if I take out the value nums of I, by default, I'll be left with the right sum. That's all I need to do. So I'll comment this guy. I'll comment this guy. There you go. So total sum becomes total sum minus nums of I, which becomes your right sum. Then you compare left sum becomes equal to total sum. You're updating the left sum here and you got the answer. Everybody crystal clear with the approach. Okay. If approach is clear, we'll go to lead code, we'll submit it. But before that, what do you think time and space complexity here? Okay, one moment. What about I is in the middle? Doesn't matter. See, we're going for I equal to 0 till I less than n. So for every element, we are going one by one. So I'll be removing that m minus I. This logic will still remain the same. Any value total sum minus nums of I, that will claim to be the right sum. Okay. The total sum is decreasing with every value. Think it. Total sum is decreasing with every value. So it will decrease with num0, then it will decrease with nums1, nums2, num3, and so on and so forth. Okay. All right, guys. What is the time complexity of this code? We take big of n here. So I'll write this as big of n. Then we take big of n here. So we'll write this as big of n. And total complexity is what? Big of n only. Space complexity, big of 1. I'm not using any extra space. Everyone crystal clear with this? Any doubts, any questions? I'll answer that question. Everybody crystal clear with this, then we can code on the lead code and we can verify. 256 and 257. There's nothing on 257, but 256. That's the whole thing I explained with the example here. See, what I'm claiming is total sum minus nums of I. I am claiming this line to be equal to right sum. What I do is I update my total sum. First, I've calculated, one moment. First, I've calculated total sum, which is a cumulative sum of the array. From that, I reduce nums of I. Basically, nums of I is what? It's just the left sum part. I reduce that left sum part. What am I left with this? I'm only left with the right sum part. So that's why I'm comparing if left sum becomes equal to total sum. If it becomes, basically now total sum has become right sum. Now total sum has become right sum. If left sum becomes equal to total sum, which is now the right sum, I return this index I. Everybody crystal clear now? Will it work for only one element in the array? It will work for everything. Let's validate. Let's write down the code. Let's submit it and we'll verify. Okay. I don't think I've submitted this question, or maybe I don't know. It's a long time I would have solved it. But anyways, let's take this code. I'm writing the code for the first time. Let's see it. Okay. I'll answer those questions. First, validate if in case we are missing any edge cases, will it pass all test cases? Because I have not solved this question as well, right? So let's see how it will work. So I'll take this guy. Let's copy this code first. Let's see how it will work. Okay. I'll take this. Let's go on lead code. Let's try to solve this first. Let's minimize this. This was the function that we had. We have written the function, and this guy should be here. This guy should be here. Fine. Now what do we need? Time comes to big of n, space big of 1. This is fine. Okay. Let's verify whether it works or not in the first place. This is good. Compile this. Compilation looks good. Let's submit it. Let's verify that. It did pass all the test case. 746 beats 100% of the submission, which is fine. Space complexity beats 64.12. That is also fine. So my time complexity is what? Time comes to big of n, which I know. Space complexity is what? Space complexity big of 1. That also I know. Cool. Anyways, you cannot reduce space complexity less than big of 1. So nothing you can do on space complexity there. All right, now let me ask what questions you guys were having. Will it work for only one element? If you look at this, let's see the constraint. It starts with one element. So yes, it will work. It will pass all test cases. Don't worry about it. It anyways pass all test cases. How to get this trick before solving it? See, the idea is the trick was based upon the brute force approach. In the brute force approach, what I was doing was I was manually calculating left sum and right sum for each and every element. That's where I got the idea. Instead of calculating left sum and right sum for every element, which is leading me to big of n square, how about I just calculate the total sum and subtract nums of I from it? That will give me the right sum. And that's where this one line of code or the trick that we are talking about has done its job. Okay. I was trying to solve with two variables. I'm not sure if right approach as compared to this trick, but it will also give the comps to big of n. Let's complete the code. We can review the code, however you are doing it, and then we can answer. There are many ways to do it. I'm not saying this is the only way to do it. This is a simple way I can think a mathematical trick and solve this question. And when I say total sum is actually the prefix sum, right? Okay, debug it once. Anybody needs debugging? I think I just explained this, but anybody needs debugging here? Okay, anything which is not clear to you, that's why you want to debug, let me know. I think if you understand this example, pretty much that's what debugging will do as well. Okay. All right, guys, that's part one of the job. Part two of the job is verifying this question as well. Although I trust lead code, when lead code say these are the same questions, so I would not be doubting them. But still, if it's the same code, why not just copy paste and verify it, right? So copy paste this code and verify on the second question also. If it is correct, it should be correct everywhere. And if it is not correct, then it is not correct. All right, let's see whether it will work here. I've just copy pasted the code, did nothing else. One thing wrong, I copy pasted in C#. I should have done it in Java. But anyways, we'll come back here. I changed the format, I guess. Yes, I did. Okay, let's take back whatever the original code was. Came back here. Now, what is giving me this error? Yeah, I will return it. Cool. Not the entire code, just till this part. One moment. I only need till this part. That's all I need. I'll come here. I'll submit it. Got here, here. That's good. Okay. Whatever the time and space quantity remains the same. Time quantity big of n. Space quantity big of 1. Let's compile it. Looks promising. Let's submit it to validate it. By the way, I've never solved this question before, but it got accepted, beat 100%, so everything is good. Cool. All right. This question is solved as well. So our code is correct, and our code is anyways will be correct. I've written this code, it should have been correct. Anyways, coming back to it. Does lead code give correct time and space quantity? Because I use nested loops, so let short big of n for time constant line section. Does it give always correct time and space quantity? I cannot say for 100% because it might or might not give it. So I'm not 100% sure for it. But if you're using nested loop, then definitely complex should be big of n square. Okay. Summation link. Okay. Summation link. Summation link. This is a summation link. Okay. All right, guys. This is fine. Let's go back to the next questions now. Everybody crystal clear with this? We have submitted on lead code. We verified. We submitted on the second question also, and we verified it's working fine and it will work fine. We talked about the approach in detail. Okay. That was the first question. The interesting part of this question was, let me quickly review it, and we review this, let me quickly revise it, and then we can move on to the second question. So this question was equilibrium index in array or pivot element in a array. This question has been asked in Microsoft and many other companies, as you can go to the list on lead code. Again, same question is available on lead code in some other variation also. 1921 is the question. What does this question talked about is, first, we have to find an index where the left sum becomes equal to right sum. And we talked about that cases there can be multiple values. The value at that index will not make any difference, so on and so forth. Okay. So what we start with is, number one, we start with for every element, we calculate left sum and right sum. And that gives us approach of big of n square. Then we realized, rather than checking it for each and every element, what if I calculate the total sum in the first place? I reduce nums of I from it, automatically I'll get the right sum. And that's the approach that I have implemented. Okay, this one line of code change has changed everything from big of n square to big of n. So time constant becomes big of n, space becomes big of n. That is the most optimized solution for this. Okay. Everybody crystal clear? Anybody has doubt, questions, follow-ups, please let me know. Moon guys, be quick. Everybody's crystal clear? Cool. If everybody's crystal clear, let's move on to the next question real quick. Give me one moment. Okay. Now for the next question, I would need to talk about subarray, subsequence, and subset. But before I go there, let me ask this thing to you guys. Subarray versus subsequence versus subset. Is everyone crystal clear with these three terms? What subarray means, what subsequence means, what subset means? If anybody does not know, let me know. I can cover that. If you guys know, I can skip that. Okay. Anyways, I got the answer immediately. So let's cover these terms. What is subarray? What is subsequence? What is subset? Okay. Yeah, we'll talk about it. It's okay. Let's talk about it. Let's understand subarray. What is subarray? What is subsequent? What is subset? Let's talk about these terms. So once we are crystal clear with it, then we can move to the second question, because second question is a question based upon subarrays. So if you don't know what is subarray, there's no point of doing that question in the first place. Okay. And while I'm explaining subarray, let me explain all the three terms. So in future code time, if you have to remember any question, you guys are crystal clear what is subarray, subsequent, subset. Let's cover it here. Let's start with subarray first, or even before that, let's take an array first. 5, 2, 1, 4, 3, 6. This is a simple unsorted array. If I talk about a subarray means substrings whenever we talk about strings. Okay, so when you hear the word substrings, substring is just a subarray. In array, we call it subarray. In strings, we call it substring. There is no difference in the fundamental approach. What are subarrays? Let's start with first. When you say subarray, it means My values must be contiguous and values must be in order. In order in the sense, same order as in original array. Same order as in original array. Okay. So the idea of subarray is your values must be contiguous and your values must be in order, means the same order as in original array. Take an example. If I'm talking about this array of 5, 2, 1, 4, 3, 6, if I talk about 5, 2, and 1, 5, 2, and 1, is it a subarray? Does it validate both the condition? Yes or no? 5, 2, and 1, does it validate both the condition? Yes or no? When we talk about 5, 2, and 1, are my values contiguous? Yes, my values are contiguous. Are my values in order? So this is contiguous, yes. Are they in order? Means 5 comes, then 2 comes, then 1 comes in my original array, which is correct. So output is yes. What about 1, 4, 3, 6? Is it a subarray? Is it a subarray? 1, 4, 3, 6, two condition. First, values must be contiguous. 1, 4, 3, 6 is contiguous, correct. In order means 1 should come, then 4 should come, then 3, then 6. So 1, then 4, then 3, and 6. Output is yes. 1, 4, and 6. Is it a subarray? Is it a subarray? Let's validate. Values must be contiguous, means 1 and 4 and 6. 1 and 4 are contiguous. 6 is not contiguous because there is 3 in between. So first condition is not satisfied. Agree? First condition is not satisfied. Second condition, values must be in order. So 1 should come, then 4 should come, then 6 should come. 1 comes, then 4 comes, then 6 comes. Is my second condition satisfied? Is my second condition satisfied? Yes, my second condition is satisfied. They are in order. 1 comes, then 4 comes, then 6 comes in the original array also. So they are actually in order, but they are not contiguous. So both conditions are must. So that is why this will not be counted as a subarray. Okay. What about 1, 2, and 5? Is this a subarray? Is this a subarray? If you talk about 1, 2, and 5, 1, 2, and 5, technically they are not contiguous and they are not in the same order as well. So that is definitely no. What about entire array? 5, 2, 1, 4, 3, 6. What about entire array? Entire array is always a subarray. So output is yes. What about individual values? Let's say 5 or 2 or anything. Individual values are always considered to be subarray as well. So output is yes. Everybody crystal clear with the understanding of subarray first. Okay. Quick in the chat. Everybody crystal clear with subarray. Okay. While I'm clearing the definition of subarray subsequent subset, let me give you the formula as well. Anybody knows to calculate the total number of subarrays? Total number of subarrays in an array of size n. Anybody? 2 raised to the power n. Okay. What about others? N square, n factorial, n factorial. Okay. Anybody else? Count their last 10 seconds. Anybody else? Total number of subarray in array of size n. N factorial minus 1. Nice. Anybody else? N factorial. Okay. These two things I can do. One is that I can tell you the formula and I can move to subsequence, or I can teach you how to get the formula. Which one do you want me to cover? Okay. See, formulas you will forget, but if you know the understanding how you are getting it, you will never forget it. Same goes if you remember, we talked about the range of integer, long, short, byte. You will never forget the range now because you know how to calculate using permutation combination. By the way, none of the answer is correct, which is given in the chat. None of the answer is even closer to the correct answer. Okay, that's fine. Let's understand how do we get the formula for subarrays. The answer is basic, simple. Stick to the basics, know what is a subarray and try to calculate it observing the pattern. So I'll take the same array, whatever the array we took, 521436, 521436. What is the size of this array? What is the size of this array? 6. Okay, cool. Now, do one thing. When we say total number of subarrays, let's write down all the subarrays which are possible. So first categories, the subarrays which will be starting from 5. So I equal to 0. What is the total number of subarrays which will start from 5? So 5 is a subarray, 5 and 2, 5 and 2 and 1, 5, 2, 1, 4, 5, 2, 1, 4, 3, 5, 2, 1, 4, 3. No, empty is not a subarray. 1, 4, 3, 6. Okay. These are the subarrays starting from 5. All agree? All agree? Yes or no? Okay. Let's do the same for 2. Subarrays which is starting from 2, which is I equal to 1. So it will be 2, 2 and 1, 2, 1 and 4, 2, 1, 4 and 3, 2, 1, 4, 3 and 6. All agree? All agree? Okay. I don't want you to write for all of them and then calculate it because I want you to observe something here. If you just be observing something, you'll get the answer immediately. Count how many are this? 6. So I'm writing it answer as total equal to 6. Count how many are this? 5. Total equal to 5. You don't need to go for 1, 4, 3, and 6. You can understand what is happening here. Total number of subarrays in an array. What is happening here? This is 6 plus 5 plus 4 plus 3 plus 2 plus 1. Yes or no? How did I get the trick? For I, total is equal to 6. The trick is just n minus I. Whatever the size of n, which is 6, n minus I. So if you start with I equal to 0, 6 minus 0 becomes 6. 6 minus 1 becomes 5. 6 minus last index will become 1. So starting from 6, there's only going to be one subarray, which is 6 itself. All agree with this trick part first. Not even a trick, just an observation part. All I have to do is I need to observe what is the total number of subarrays starting from one particular element. I just write it down for 2 elements and I observed a pattern. You want to write for all 6? Go ahead, write for all 6. You'll still see the same pattern. I observed a pattern is that the number of subarrays starting from an index is directly related to the n minus I value, right? So if we start with first index, it will be n. So in this case, 6 minus 0 will be 6, 6 minus 1 will be 5, and so on and so forth. 6 minus 5 will be 1. Total number of subarrays becomes 6 plus 5 plus 4 till 1. What is this, AP or GP? AP or GP, quickly in the chat. This is arithmetic progression, which you call as sum of first and natural numbers. This part will become 21. So if I have to take for, let's say, n size, this was for 6 size. If I have to do it for n size, n minus 1, n minus 2, till plus 1, which is same as 1 plus 2 plus till n minus 1, not n minus 1, till n. So that will become n into n plus 1 by 2, sum of first and natural numbers. All agree with this? That is the correct answer. Total number of subarrays of size n is nn plus 1 by 2. So I've given you the formula and I told you the reasoning behind the formula also. Okay, n minus I part. All right, guys, that's all on the subarray. One more thing I can cover, I can just write down the code as well. So if I have to print all the subarrays, I equal to 0, I less than n, I plus plus. For j equal to I, j less than n, j plus plus, you can just print the value of I of j. That's it. Time comps will become big of n square, and that's it. So in the subarray part, what have I covered? On the subarray part, I covered what are subarrays. We walked through the example, two conditions, values must be contiguous, values must be in order. Then we talked about formula for subarrays, and I gave an example how to calculate it. Then we talked about the total number of values, which is n plus 1 by 2, and I've given the code to calculate the subarrays or print the subarrays. Anybody has any doubt, any questions? Is subarray crystal clear to everyone? Subarray is crystal clear to everyone. Anybody has any doubts, any questions? If somebody asks anything related to subarray, can you explain it very well? And subarray is just substrings in the case of a string. That's all. Okay. All right, guys. If subarray is good, let's move on to subsequences. Subsequences. What are subsequences? Let's talk about it. In subsequences, first I'll take the same array, whatever that array is, 5, 2, 1, 4, 3, 6. In subsequences, we have two conditions. Number one, values need not be. Read the word need not be contiguous. If they're contiguous, well and good. Values must be in order. In order means same order as in original array. Okay. Now let's talk about the same examples that we have taken here. So this guy we have taken the example. Let's take this. We'll validate how many of these are subsequence, how many of them are not. I'll remove this guy, this guy. Okay. So what are the two conditions? Values need not be contiguous. If they're contiguous, well and good, but they must be in the same order as in the original array. Starting with 5 to 1. Is 5 to 1 can be classified as subsequence? Yes or no? Can 5 to 1 be classified as a subsequence? Yes or no? So first condition, need not be contiguous. Is 5 to 1 contiguous? It's a contiguous. Do I have any problem with that? I don't. Values must be in order. So 5 should come, then 2 should come, then 1 should come. So output is yes. 1, 4, 3, 6. If I talk about 1, 4, and 3, 6, these values are contiguous, which is fine. These are in order, which is also fine. So output becomes yes. What about 1, 4, 6? So 1, 4, 6, first condition, values need not be contiguous. Is 1, 4, 6 contiguous? No, 1, 4, 6 is not contiguous. But do I have a problem with that? Do I have a problem with that? No, I don't. If they're contiguous, well and good. If they're not contiguous, completely fine. Second condition is a must. Must means they should be in order. So 1, then 4, then 6 should come. 1, then 4, then 6 should come. So this becomes a subsequence. Remember, this was not a subarray, but this is a subsequence. Everyone crystal clear with this? Everyone crystal clear with this? Okay. Now coming to 1 to 5. So in the case of 1 to 5, is it contiguous? It's not contiguous. We don't care, to be honest. Values must be in order. Is 1 to 5 in order? 1 should come, then 2 should come, then 5 should come. The answer is no. So output becomes no here. 5 to 1, 4, 3, 6, the entire array. The entire array is considered to be a subsequence. Output is yes. Individual elements are always subsequence. Output is yes. This is subsequence part. So one thing which is very clear, we don't care whether the values are in contiguous. If they are, well and good. If they are not, completely fine. Values must definitely be in order. Everybody crystal clear with subsequence. Okay, cool. Now let's move to the last part, which we call as subsets. Okay. What are subsets? Let's keep the same array here. 5, 2, 1, 4, 3, 6. Subset is any possible combination any possible combination that you can make from elements of the array. Any possible combination you can think of. Values need not be contiguous. Values need not be in order. Okay. It doesn't matter if they're contiguous. It doesn't matter if they're in order. Any possible combination, as long as the value exists in the array, everything will be a subset. And this is where the total number of subset becomes, which we call as power set, 2 raised to the power n. This is what you have understood in a Venn diagram also in mathematics. When you create a power set is a combination of all subset, and that is 2 raised to the power n for a set of size n. I hope all of you guys remember. In your mathematics, in Venn diagram, you would have heard a word called power set. Power set is a combination of all the subset, which is 2 raised to the power n combinations. Okay. All right. Anyways, coming back to it, let's verify for these guys real quick. There you go. So starting with this, is 5 to 1 a subset? Is 5 to 1 a subset? Yes. 1436 subset? Yes. 146 subset? Yes. What about 1 to 5? It's not a subarray, it's not a subsequence. But is it a subset? We don't care about order, we don't care about contiguity. So this is also answer yes. Entire array, yes. Individual element, yes. But if I say 1, 2, and 7, is that a subset? The answer is no. So the only condition of subset is you can take any possible combination from elements of the array. But if element itself is not present, 7 is not present, then you cannot call it as a subset. Everyone crystal clear with this? Come on guys, quick in the chat. Okay. Let's quickly verify this. So quickly revise this, what we talked about. We talked about subarray versus subsequence versus subset. I've cleared your understood. I believe I have cleared all your understanding of subarray, subsequence, subset. Subarrays are called substrings in the case of a string. So same logic, same definition. In the case of subarray, values must be contiguous, values must be in order, right? We talked about formula for subarray. We calculated the formula. How do we get that formula? We talked about the code, time and space, complexity. Subsequences, value need not be contiguous, but values must be in order. We talked about subsequence also. Subsequence generally does not have a formula because, again, the values need not be contiguous. You do not have enough number of values for calculating the size of a subsequence. Subset, any possible combination from elements of array need not be contiguous, need not be in order. Okay. Now, empty array we do not consider as a subarray. So output will be given as this one. Anything which is part of the array will make a subset out of it. Okay. Everybody crystal clear with this now. Everybody crystal clear with this now. Subarray, subsequence, subset. Anybody has any doubts in the definition of anything? Let me know. Okay. Now, last thing to cover. How do we look at the bigger picture? Power set, empty set included, yes. In a power set, empty set included, yes. Subset contains subsequences. Subsequences contains subarrays. So this is how it looks like. Okay. In terms of syllogism, we read it like this. All subarrays are subsequences, and all subsequences are subsets. Okay. This is how we look at the Venn diagram. The bigger is subset, so I'm calling it as SU. Inside that, we have subsequence, I'm calling it as SS. Inside that, we have SA, which we call as subarray. So all subarrays are subsequences, but all subsequences are not subarrays. All subsequences are subset, but all subset are not subsequences. Everybody crystal clear with this Venn diagram? Any questions, please ask. Come on guys, quick in the chat. Related to this Venn diagram, any questions, please ask. If everybody is clear, let me know. Okay, let me clear this. Let's come back here. Now we can move to the question number 2. The reason I covered all of these theories because the question number 2, when we'll use this. Use what? Use what exactly? Subarray subsequent subset. When we'll use this? Whenever the question will be related to subarray subsequent subset, so you should know what the question is asking. That's why. Okay. All right. Now let's move to question number 2. The reason I have to cover all of this is because question number 2 is related to subarray. And if you don't know what is subarray, there's no point of doing question number 2. Question number 2 is a really good question. This has been asked in Cisco, and it has a follow-up which has been asked in Google, which I'll give you for homework, and we'll connect if you can solve it or not. You should be able to solve it, by the way. Question is, find if there is any subarray with sum equal to 0. I'll copy this. What Google asked was this, sum equal to k. Okay, let's start with 0, then we'll talk about k. The question is, you are given an array of positive and negative integers. Find if there is any subarray, remember the word subarray, with sum equal to 0. Let me check if this question is on lead code. I doubt if it is. Second one is there for sure, but let me see if the first one is available as well. Or if they have some variation of it being available. Length of the largest subarray with equal sum. I think lead code has that. Cool, no worries. There's one called contiguous array. No worries, fine, no worries. Cool, we'll solve it here. The question is, you're given an array which contains positive and negative integers. You need to find if there is any subarray with sum equal to 0. Let's take an example. If I talk about 4, 2, -3, 1, and 6, what do you think? Output is true or false? Output is true or false? Okay. Which is the subarray that you think can give sum equal to 0? Do you see any subarray which can give sum equal to 0? Correct. If you look at 2, -3, and 1, the sum becomes what? Sum becomes 0. So output becomes what? Output becomes true. All right. This is the solution that you need to come up with. Now, first thing first. If you have to check if there is any subarray with sum equal to 0, first thing, the first important part is this line required in the question? Is this line required in the question, or can we remove that line? Just answer required or not required. That should be fine. Okay. Required, required, required. Okay. Remove required, not required. Okay. Not required. And that's very conflicting answers. Cool, guys. Let's understand this. If there are not positive and negative integers, can the sum ever become 0? You need equal amount of positive, equal amount of negative to make it 0. So answer is this is required. Yeah. Do we need to specifically call out positive and negative? No, but it's important to mention that there are positive and negative integers. Okay. All you need to do is you need to find if there is any subarray with sum equal to 0. And this is the problem statement I talked about. Now the function that you need to complete is write a boolean is subarray exist, subarray with sum 0. You're given an integer array, and that's all you're given. This is the function that you have to complete. Any doubt in the problem statement? Any doubt in the problem statement? Come on, guys, quick in the chat. Okay. If everything is crystal clear, you guys know what to do. I'm giving you this function right here in the chat. Range of values, you can finish within the range of integers. So I'll keep the same constant as in the previous question. Let's stick with the same constant. Okay, you can code with and then try to optimize as much as you can. These are the constants. Okay, this is the function that you have to complete. I'm just putting that in the chat. Feel free to code this in any language of your choice and give me the answer. Remember, you have to return true or false. You have to just return a boolean here. Okay, come on, guys. Question clear to all? Any doubt? Anything which is not clear? You're given us an array. You just need to check it if there is any subarray with sum equal to 0. If it is, return true, otherwise return false. Any doubt, any question? Okay, I'll take that as no doubts. That being said, guys, try to solve it within next 5 minutes because we have roughly 15 minutes pending. I don't want to take it to the next class. And anyways, I'll be on vacation for after this session, so I don't want to elongate too much for it. Okay, and we might need to extend the class for that, but let's do it real quick. Problem is clear. Everybody is clear with the requirement. I've given you the function to complete. Now I'll leave it to you guys. Quickly code it. Once you are done, just let me know. We can start with the discussion. Okay, your time starts now. All right, guys, I think enough time. We'll start discussing because we'll definitely override with the time that we have. Okay. Go to discuss. Let's start discussing. We only have only 3 minutes left, so we won't be able to complete it. So this class will be extended for 10-15 minutes if everyone is okay with that. Does anyone in a hard stop? Let me know. If everybody is okay with that, we'll still spend 10-15 minutes to go through the code and the full shape. Okay. All right, guys. That being said, let's start with the solution. First thing first, let's take the example that we talked about. 4, 2, minus 3, 1, and 6. So we got the output to be true. Let's take this guy. Try to understand this question first. When we say prefix sum to be 0, right? Or subarray sum to be 0, that is actually prefix sum to be 0. So what is the definition of prefix sum in the first place? The definition of prefix sum is array of 0 plus array of 1 plus till array of 5. All agree? When I claim that prefix sum becomes 0, or prefix sum of I becomes 0, let's say for example, it means array of 0 plus array of 1 till whatever that index I, that becomes 0. Basically, array of 0 till I becomes sum 0. All agree with that, yes or no? If I claim prefix sum of I becomes 0, means sum of all values from 0 till I becomes 0, yes or no? Come on guys, quick in the chat. Okay. So array of 0 to I, starting from 0th index till ith index, is that a subarray, yes or no? Is that a subarray, yes or no? So that means a subarray which is starting from 0 index with sum equal to 0 can be easily found if the prefix sum contains a value 0. So I calculate the prefix sum array of the array. If in that prefix sum array a value is 0, means the sum of values from 0 index till that particular index is 0. So there is a subarray which starts from 0 index with sum equal to 0. Everyone is crystal clear with this, yes or no? Just calculate the prefix sum of the array. If any value in the prefix sum is 0, means there is a subarray starting from 0 index with sum equal to 0. Yes or no? Okay, let me repeat it again. Let's start repeat again, guys. What is the definition of prefix sum? The definition of prefix sum of I is sum of all values from 0 till that index I. This part clear? We have done this multiple times. Okay. Now, if I claim if any value in the prefix sum array becomes 0, what technically does that mean? That technically means sum of all values from 0 till that index I becomes 0. Line number 506, all agree. Line number 506, all agree. Quick in the chat, guys. Okay. So what is that 0 to I? That 0 to I is a subarray. If I go from 0 to any random index I, that is a subarray. So what are we claiming? If in my prefix sum array, if for the given array I create a prefix sum array, in that prefix sum array, if any value is 0, means there is a subarray starting from 0 index with sum equal to 0. All agree with this, yes or no? Okay, that's all I said. That is first category of the subarray. the subarray which is starting from 0 index with sum equal to 0, we can quickly find them out by putting the prefix sum value is 0 or not in the prefix sum array. This should be straightforward, guys. There should not be too much time spent on this. Okay. Okay. If this is good, now let's move on to the next one. But is it mandatory that a subarray has to start from 0 index? Is it mandatory that a subarray has to start from 0 index? The answer is no. If I talk about this 4, 2, -3, 1, and what it was 6. In this case, where the output was considered to be true because the subarray, which is 2, -3, and 1, this is starting from 1 index. Will this approach be able to find this subarray? Will the first approach of calculating prefix sum to be 0 will be able to find this subarray? The answer is no. It is only finding those subarray with sum equal to 0 starting from the 0 index. But what about those subarrays which still has the sum 0 but they start from a non-zero index? This approach cannot find it. For that, we have to think through something else. Think of some other approach. Okay. That some other approach is what I'm going to talk right now. Start here. I, J, and that's it. Okay. Now, what is this I and J? Assume there is a subarray starting from I to J, which has sum equal to 0. And obviously, I is non-zero. We'll talk about it. We'll talk about it. Assume there is I, there is J, there is two random indices. I is not equal to 0. There is a subarray going from I to J with sum equal to 0. So this is the second case we are talking about. We have a subarray with sum equal to 0 starting from a non-zero index. This part clear? We have a subarray starting from a non-zero index but with some 0. That's what we're trying to find out. Now, how do we find out that? Let's observe something. If I say prefix sum of I, what will be that? That will be sum up to ith index values. So that will be array of 0 till I. And if I say prefix sum of j, that will be sum up to jth index value. That will be array of 0 to j. All agree that's a definition of prefix sums. Nothing much to mention here. All agree with that. Come on, guys, quick in the chat. We should not take this much time on this. Okay. Until now, everything is fine. Things become interesting when these two become same. If prefix sum of I becomes prefix sum of j, now understand what is happening. What you're claiming is sum of this part and sum of this part is same. Agree? When you say prefix sum of I is k and prefix sum of j is k, what you are claiming is 0 till I sum is same and 0 till j sum is same. This everyone agrees? This everyone agrees? Okay. That is only possible in one condition. What is that one condition? If the values between I and j, they are not contributing to anything. Their sum becomes 0. They are not contributing to anything. That is the only condition when it is possible. All agree? Okay. Let's clear this. Let's come back here. Let's talk about this. So if I claim that sum of values from I to j becomes k minus k, that becomes 0. Another terms, I can simply say prefix sum of j is nothing. It is prefix sum of I plus array of I to j. So if array of I to j becomes 0, only in that case prefix sum of I will become prefix sum of j. Array of I to j will be what? Array of I to j will be a subarray. So a subarray starting from any random index. Random index in the sense not 0. any random index not 0 with sum equal to 0. So these are the two tricks we talked about. So basically two cases. Number case, in one case, a sub-array with sum 0 starting with 0 index. In that case, the prefix sum will contain value 0. Simple. Second category, sub-array sum with 0, but not starting with 0 index. In that case, my prefix sum will contain duplicate. All agree with that? Yes or no? Come on, guys, quick in the chat. Only two possibilities are there. Subarray with sum 0, either A, it can start from 0 index. That's what I'm repeating. Subarray with sum 0, either A, it can start with 0 index. In that case, my prefix sum will contain 0. Or B, it does not start with 0 index. In that case, my prefix sum will contain duplicate values. That's all I need to check. So I need to check prefix sum is 0 or prefix sum is duplicate. That's all I need to check. Okay. Let's quickly cover this with an example that will make it crystal clear. I'll come here. Let's take example 1 and example 2. Example 1, subarray with sum equal to 0, and they are starting from non-zero index. Okay. And then I can take example 2, which is subarray with sum equal to 0, starting from 0 index. So example 1, we have this array 4, 2, -1, 3, and 6. We have a subarray which is starting 2, -3, and 1. Just starting from 1 index. Can you quickly tell me the prefix sum for this array quickly in the chat? What is the prefix sum array for this array? Quick in the chat. Come on, guys, be quick. What is the prefix sum array for this array? Quickly in the chat. 4, 4 plus 2 is 6, 6 minus 1 is 5. What next? 4, 2, this was -3, my bad. 4, 4 plus 2, 6, 6 minus 3 becomes 3, 3 plus 3 becomes 6. And then what? 6 plus 6 becomes 12. Did you miss anything? What was the array? 4, 2, -3, 1, and 6. 4, 2, -3, 1, and 6. Okay, that's fine. So 4, 4 plus 2, 6, 6 minus 3 is 3, 3 plus 1 becomes 4, 4 plus 6 becomes 10. All agree? 4, 6, 3, 4, 10 would be the correct answer. Okay. Do you see any value repeated here? Yes, 4 is repeated here. Part 1. This is the first category. Subarray sum is 0 starting from non-zero index. So prefix sum will be repeated. Second category is super simple. Subarray sum starting from 0, and that will in that case prefix sum will contain 0. So let's put -1, 2, -1, 5, and 6. Which subarray has sum 0? Subarray is -1, 2, and -1. This is starting from 0 index. Okay. And if I talk about the prefix sum here, prefix sum will be -1 plus 2, 1. This becomes 0. This becomes 5. This becomes 11. So 0 is contained in the prefix sum. These are the two possible cases. Everybody is clear with this. Case number 1 and case number 2. So either your subarray can start from 0 index or they can start from non-zero index. If they start from 0 index, then prefix sum will contain 0. If they start from non-zero index, then prefix sum will be repeated. Everyone crystal clear with this? Okay. If everybody is clear, let's quickly go to the approach, then we can go to the code part. Approach is what we just discussed. We calculate the prefix sum array. What do we do? If that prefix sum is equal to 0 or prefix sum is equal to repeated or is repeated, I return true, else I return false value. That is my approach. Everyone crystal clear with this? Come on, guys, be quick. Okay. If everyone is clear, let's quickly move to the code part and we can implement the code. What is the function we need to complete? Is subarray with sum 0. Copy this, bring it here. Let's write it down the code. If I have to check whether a value is duplicate or not, what do you think is the best data structure to use? Both map and set are good. Okay. Map is usually used for the mapping part. For responding to a key, you will have the value. So set is the more appropriate data structure, but technically speaking, you can use both map and set. Okay. I'm going to go ahead with a set here, has set of integer. Let's call it as a set equal to new has set of integer. You created a set here. What do I want? I define something called prefix sum is equal to 0. What next? For I equal to 0, I less than n, I plus plus. What am I doing here? Prefix sum plus is equal to array of I. All I need to take care of is two conditions. First, if my prefix sum becomes equal to 0, two pointer is not the right solution here. Prefix sum is the better solution here. Or my set dot contains prefix sum. In that case, I return true. What are the two conditions? First, if prefix sum becomes 0 or prefix sum contains in the set already, then we say return true. And in my set, I will add the prefix sum part. And then I can return the false from here. Everybody crystal clear with this? Quickly give me clear on the chat. Two pointer to check whether it contains, again, that will become a search, right? That will become a linear search because this does not need to be a sorted array. So that will become big of n square code if you're using by array. Okay. Now coming to the time and space complexity part of it, guys. This is big of n code. If you look at this, and what about this guy? Lookup in a set is big of 1. So first condition is this, and second condition is big of 1. So my total complexity becomes what? It becomes big of n. My space complexity becomes big of n because I used a set here. Everybody crystal clear with the code, approach, time and space complexity. One moment, guys. Everybody crystal clear with this? Okay. Okay, see, still one question based upon how do you explain it on true condition. See, we verified for the two cases. There are two cases possible. One moment, guys. There are two cases possible. The first case is a subarray. Okay, understand the very first thing. We need to find a subarray with some 0. Now, there are two possibilities. That subarray can start from a 0 index or it can start from a non-zero index. If it starts from a 0 index, we validate it will contain a 0 in the prefix sum. If it not start from a non-zero index, we validate the prefix sum will contain repetitive values. So that is what I'm putting in the if condition. If my prefix sum becomes 0 or this is the or condition, it contains the prefix sum, means it's a duplicate, then I'll returning true here. Okay. Cool, guys. Everybody clear? Yeah, if you want to create a prefix sum array separately, you can do that. But anyways, what I'm saying is if you have to check whether array prefix sum contains duplicate or prefix sum is 0, you anyways need to contain a duplicacy check. If you have to check whether a value is present in an array, whether it's a value is repetitive in an array, for that also you need a big of n square code if you are not implementing set or map. Okay. All right. If you want to check with like putting first pointer in the beginning, last pointer in the end, and just comparing whether first and second pointer compared, you can do that also. Okay, that's I think you are talking about that. Okay. All right, guys. Any more thing? Can we use prefix sum for all subarray related question? No, that depends. That completely depends. This question was specifically asking me subarray with sum equal to 0. And wherever I see the word sum, that's when I got the trigger. I can use the prefix sum here. Okay. So it all depends on the question. These two questions are really good questions from the interview perspective. And I'll give this one question for homework as well. I'll just come back at the later part. But just wanted to make sure everybody's crystal clear with this question. Subarray with sum equal to 0. We talked about approach. We talked about two cases. We read down the code. We talked about time and space complexity. Okay. All right, guys, we're 15 minutes ahead of the session. Let's quickly revise what we discussed as part of today's session, and then we can wrap it up. One moment, I'll give it. I'll answer the questions. Let's quickly revise it, and then I can give it. So first thing first, we are done with the prefix sum questions, which is great. Now we are pending with majority element, product of array, mud sort, wiggle sort, those kind of things. So we'll talk about this question. These are also some good algorithm questions before I move to the next data structure, which is going to be linked list or stacks. We'll discuss whatever that is. Two questions we covered based on the theory of prefix sum. Number one, finding the equilibrium index in an array. We talked about what is equilibrium index. We talked about the edge cases. What if multiple equilibrium index existed? What about the even size array, empty index, one value, etc., etc. Same question is available in lead code twice. One is lead code 724, one is lead code 1991. So we solved all of them. We start with a brute force solution using two nested loops. We calculate left sum, right sum for each element and square big of 1. Then we come with the optimized solution with a simple mathematical trick. This is a really good trick if you would have, I've anyways understand, I made you understand it, but it's a really good trick to reduce the time complexity from big of n square to big of n. So we pass that, submit on lead code, bits 100% of the submission, time comes to big of n, space big of 1. Okay. Then for the second question, we need to understand the difference between subarray versus subsequence versus subset. So I clarified the difference of subarrays. I gave you the formula for subarrays. How did we come with that formula? I explained that as well, along with the code and complexity. Then we move to subsequences. Subsequences need not be contiguous. So first condition is changed. We talked about subsequences. We talked about subset, total number of subsets, etc., etc. So all subsequence, all subarray are subsequence, all subsequence are subset. Then we talked about another really good question. Find if there is any subarray with sum equal to 0. So we first understood the question and then we validated there are two possibilities, two cases. The subarray with sum equal to 0, either it can start with the 0 index, in that case 0 will be contained in the prefix sum, or it can start from a non-zero index, in that case prefix sum will be repeated. So we validated that approach, we write down the code, time and space complexity, everything we discussed. And then there's one question for homework which I'll give you guys to try upon. Any doubts, any questions, please let me know. Yeah, I'll talk about vacation plan one moment. Any doubts, any questions anybody has? Why do we need to understand the formula for subarray? I gave you option, guys. I could have directly told you the formula. I asked you, do you want me to explain or do you want to just know the formula? You guys said you want to know. That's why I explained it. Otherwise, I would have directly given you an n plus 1 by 2. So I think the question would be to you, why do you want to know the answer? But anyways, if you are good at memorizing, go ahead. But you should know how the formula came in the first place. Okay. All right, guys. What next? Linked list stack implementation Python using arrays. Do you recommend continue coding in Python? See, in DSA, it doesn't matter if you're coding in whatever language. Just make sure you write production ready code, clean modular code in whatever language you want. I'm never a language specific developer. As a software engineer, you should never be language specific in the first place. That being said, there would be one language you would feel more confident in, so feel free to use that language. In DSA questions or problem solving questions, language is never a barrier as long as you can write a clean and production ready code. Okay. For your question for assignment provided for today's session, yes, assignment will be provided to you. We'll cover sliding window. We'll cover sliding windows later in the syllabus. Okay. All right, guys. Any more questions related to this class or this session, whatever we discuss in this session? Yeah, if you have to return the subarray, if you have to return, there can be two variations. You have to either count or return it. So if you have to count it, you can just do plus plus count. If you have to return the subarray, in that case, I will use a hash map. What I'll do in the hash map is, let's say if I have in that hash map, wherever I got the index 0, so I'll go till that index. So I'll take it from 0 till this part and I'll print the value from that array. So I can use a map there. Okay. All right, guys. Any more doubts in this question or this question in the sense, whatever we discussed in today's session? Everybody clear? Any questions? Any doubts? Okay. Now coming to the vacation plan before I wrap up the session. As I said, I'll be on vacation after this session. So I'm not sure if some other instructor is taking or whatever the directions that you have received it. I'm not 100% sure. I'll return back in April, after first week of April, and then I'll continue with the classes. But as per my understanding, some other instructor should be taking it. I don't know if you have received any information or communication regarding that, but I will be traveling, and once I'll be back, then I can take care of that. Okay. No info yet. If there's no info yet, I think I'll let your course coordinator communicate. They might be finding a substitute teacher, whatever that is, and then you guys can take from there. Okay. All right, guys. That being said, let's wrap up the session here for today. And thanks for joining in. Let's catch up in. I will catch up after once I'm back. In case there's other instructor, they will continue from it. Okay. Thanks for joining in. Have a good one. We'll connect again in April.